Hi, I'm Ryan. In this video, you and I are going to chat about the OSI model and how information moves from one computer to another. The Open System Interconnection Model, commonly referred to as the OSI model, was published in 1984 by some smart people from around the world that wanted to standardize a mental framework to explain network architecture. They chose 7 layers. Before the OSI model came along, explaining the network architecture was more nebulous. We will talk through this in bite-sized pieces. I'll be describing what happens to each of the 7 layers using the example of ordering a pizza. So without further ado, layer 1, the physical layer. This might be a Cat5 cable bringing broadband connection from your internet service provider, your ISP, or the little antenna in your smartphone picking up the signals from the big antenna on the cell phone tower. At layer 1, we are trading back and forth a specific pattern of bits, lots and lots of ones and zeros. These ones may be the flashing light at the end of a fiber optic, or it might be the electrical charge passing through a copper wire. Anytime light or electricity is not transmitted, that registers as a 0. Layer 2 is our data link layer. It adds a frame of extra information to make sure these bits reach their final destination. This information comes in the form of a media access control address, your MAC address. The MAC address can kind of be thought of like your computer's home address or your computer's social security number, which will allow the frame to know exactly which pizzeria should be receiving your order after it travels through the network. Switches and bridges communicate together at the data link 2 to send frames to each of the specified MAC address. Layer 3, the network layer. We'll take your framed information, box it up in a packet. Just like sending a package, layer 3 places the frame into a packet with both the recipient's IP address and the sender's IP address. Routers communicate around the world with each other by communicating on shared protocols. These routers send packets to the general destination. Layer 4, the transport layer, chooses how data segments will be sent and serves as a quality control. If the transmission needs to be complete, like sending an email, an internet uses Transmission Control Protocol, TCP. If speed and real-time response is the priority, like a phone conversation is the priority, the internet will use User Datagram Protocol, UDP. TCP is basically a protocol used when it is important for all the data to reach its destination intact. TCP does this 3-way handshake, kind of like, hey, yeah, I got your data. Cool. You got my data? Be ready. I want to send you some more data. In UDP, transport, all the packets are sent out, but if you're talking through a tunnel and lose cell phone tower connection, the internet does not go back and find the lost voice packets. UDP is less about being 100% sure the data transmission gets through and more designed about providing a constant data stream. So things like games or video calls will use this method to make the live communication. Layer 5, the session layer. All these bits of ones and zeros have not been processed by the computer yet. The session layer provides connection between applications. Layer 5 communicates with your Visa credit card approval with the Papa Ryan Pizza. By contacting the server of paparyanpizza.com, the session layer can negotiate with the user's computer and the funding source server on the best encryption to use. Layer 6 is responsible for checking out your order and translating all the pretty code to create the application layer back into a language more easily understood by computers. Thankfully, paparyanpizza.com was actually https://paparyanpizza.com. What does this mean? Well, the HTTPS means that the website was using a secure method of communicating with the computer. So all their pizza pages were encrypted to make sure only you could see their delicious toppings. This also means that your login information in your order was also encrypted. The presentator, being the bro that he is, not only translated your order to ensure that Papa Ryan Pizza would be able to read it, but also turned it into a secret message to make sure nobody else could steal your order information, like your credentials, your address, or the dirty little secret that you put pineapple on your pizza. I'm not mad, just disappointed. The presentation layer presents the application and user in a comprehensible way. Presentation layer concepts include data conversion, such as ASCII, image formats such as GIF, and JPEG, and TIFF. Layer 7, the application layer, is the layer that most users are familiar with. This is where you can see the various application, games, and web pages being displayed on your screen in all their glory. Basically, this is the layer made up to be seen by your pizza customers like you and me. So we're choosing our toppings and finalizing our order on PapaRyanPizza.com. We're seeing the application layer. So what happens next? Well, now everything basically happens in reverse as the data travels back through the network. The application layer displays the code to the presentation layer. The presentation layer provides syntax to the session layer. The session layer contacts the server for the transport layer. The transport layer moves segments for the network layer. The network layer moves packets to the data link layer, and the data link sends frames to the physical layer. Within the IT industry, we will only see the mental framework model sheets. But for networking professional, using a phrase like, "Our router has a signal, but the laptop is not staying connected. This looks like a layer 2 problem," can be very helpful in network troubleshooting. A mnemonic that you may like to use that starts like at the physical layer, goes up to the application is, "Please do not throw away sausage pizza." I hope this information has been helpful, and thank you for viewing.